Okay, go to page 127. Page 127. One 124. That's the last page. You don't have these pages. So problem no, because I'll show you a table right now. You just need to copy the table, but I'll be uploading the full book, so you'll have those pages eventually. Okay. So today we'll be hopefully wrapping up everything. Or combating it. There's this one chart you need to understand. So last class, if you remember, we did the first part, 11.1. So just to quickly recap, mainly the alpha scattering experiment, the structure of an atom, the idea of the nucleus, nuclear atom. I'll show you a video, animation of that right now. The idea that your nucleus can become unstable when what happens? Do you remember? No, unstable কখন হয়? Yeah, so the number of neutrons and protons is imbalance, and the reason behind that is the protons and neutrons, right, are like paired up, and that pair is very stable because they apply a bond on each other known as the strong nuclear force. So strong nuclear force, if you explain strong nuclear force is a force of attraction, right, between nucleons, protons and neutrons, right, and the protons and neutrons are bound by this bond. It's not like a chemical bond. It's much more complicated than that. It's the strongest force in the universe, the strong nuclear force, right? Nothing competes with it. Now, there's a catch though. This force can only act at a distance that's similar to the distance between a proton and a neutron. If that's the strongest force in the universe, right? Why not like build bridges, build it out of that? The strongest in the universe, right? Problem of attraction force can only act at a distance that's just the distance between a proton and a neutron. So if it's little further than the proton and neutron, it doesn't work. To give you an idea, right? You can there's a ball here, right? It can act the neutron of proton attraction because the gap is bigger than the size of the neutron. So it's just between a proton and a neutron gap that we can bond if it goes like the bond. So that means your nucleus and just the protons and neutrons bind that. It would regularly problem. They combine. So therefore, combine that in the nucleus, right? You have many protons and fewer neutrons. So they combine for the pair. The idea is that your proton in an ideal scenario must have a neutron. It's the pair in system, right? But যদি বেশি প্রোটন থাকে ওদেরকে এক্সট্রা কেউ নাই, সো তখন নিউক্লিয়াস unstable. About বেশি neutron থাকলেও problem because who's going to keep the neutrons in their place, right? So that makes your nucleus unstable. Unstable, what do they undergo? Radioactive decay. And everything that I just mentioned so far, we did in O levels. That's the whole logic behind radioactive decay, right? Now, radioactive decay, there are multiple ways in which a nucleus can become stable. The most popular way is an alpha decay. Alpha decay te ki hoy ekta helium nucleus release kora hoy, and then it's an alpha particle. That is the most stable, most common form out there. Eta kokhon prefer kora hoy when there's too many neutrons out there. So when the system has too much neutrons, a decay টা prefer করে. So like uranium, plutonium, polonium, all these have excess neutrons in them, right? What kind of decay will they undergo? Have to wait for কোনটা 1 or 2? So you have protons and neutron imbalance, right? So if you have proton and neutron imbalance, it becomes unstable and it undergoes alpha decay. But there's something else called a beta decay as well. What's a beta decay? Beta decay হচ্ছে যখন proton number বেড়ে যায়, neutron number কমে যায়. So we talked about beta decay. Beta decay কি একটা neutron breaks down to a proton and an electron, and that's what we thought originally. But there's a problem there. Problemটা কি বলি একটু, because এটা last class we address করি নাই. Proton, like a neutron just splits into a proton and an electron, right? And we thought that if the split happens, right, proton edike, electron edike, that should be it. It's a very perfect equation. If you think of a neutron, proton plus electron, balance and everything, right? But we found that the electron kept on coming out with energies, like different energies and different momentum that did not match the momentum of the proton. Why is that a problem? When I'm like a neutron stationary, right, it breaks down into what? Like a proton, like an electron, right? And when we find the momentum of the electron and we find the momentum of the proton, right, match করে না. Why is that a problem? No, but yeah, the fundamental law of the universe, conservation of momentum, right? So momentum conserve হচ্ছে না এখানে, and because momentum conserve হচ্ছে না, that's the problem, because the universe never fails, right? That's when we realized that we made a mistake or we weren't aware of something happening. That যখন এই neutronটা breakdown করে, it forms a proton, it forms an electron, but also it forms this very small particle called an electron neutrino, anti-electron neutrino, right? A particle কিছু momentum দিয়ে দেয়. And we didn't know that originally. Eventually, we came to know about it. And that's when we discovered this new class of particles, যেটা আজকে আমরা শিখবো, okay? So in the last class, I showed you some equations here, these, right? So here you'll find last day there's an anti-electron neutrino, electron neutrino. These particles are the ones that were missing. And that's the reason why electron energy vary করতো. কারণ electron আর neutrinoটা energy কি করতো? Share করতো. Share ratio কি হতো? Random. So মাঝে মাঝে 1:99, 50-50, 60-40. So but আমরা কি দেখতাম? 99, 60, 40. Rest of the energy কই খুঁজে পাওয়া যেত না. Eventually we found this. Why is it so elusive? মানে এই জিনিসটা বের করতে এত টাইম লাগছে কেন? It was a very recent discovery, right? মানে in terms of science. Because it's neutral. And neutral particle detect করা খুবই difficult because they have no charge, they have no field, there's nothing that reveals their existence, right? On top of that, to add to the problem, it's one of the lightest particles in the universe. So therefore, সব মিলে it was very difficult to find out. We had it in theory, I think 2001 বা 1998 ওরকম time they found the actual evidence of it. Okay, so anyways, that's the thing that we saw last class. So আজকে কি করব? আজকে I'll be teaching you the hierarchy of particles. It's a chapter that's been added. A chapter to, in fact, their Cambridge syllabus started in 1985. 1985 it start to the course syllabus, right? Like the one you're doing is 1985 syllabus. এই চ্যাপ্টারটা এক্সিস্ট করতে পারতো না, because everything that I'll be teaching you right now has been discovered after 2001, মানে most of the stuff. So এখন now it makes sense to have it in your syllabus. Okay, so because এর আগে your syllabus ended with an atom, and the atom has a nucleus, and what does the nucleus contain? Protons, neutrons, and what's in the shell? Electrons. And that was it. We thought that's the end of it. That's the smallest bit of the universe, right? But now we know that's the start. It goes down multiple layers. Okay, with multiple layers go all right. So yeah, page 127 or partial blank page, you're going to start this. Yeah, there are both. What's holding? Adjacent pairs. Yeah, which let's say there are 3 neutrons and 1 proton. Who's holding the other 2 neutrons together? That's a good question. Sure, there's a question here to explain Kori. Though it's like beyond the scope of our syllabus, but I feel like jana dorkar because A level say A2 to shikhabe na to oneke jinishta, which is there in Edexcel though. So his question is that you have a proton and you have a neutron here. And I just mentioned that the proton and neutron are bound together by this force called a strong nuclear force. Okay? So and what binds them together actually? Is it like electrostatic force of plus and minus? No, that's not. It's not, far from it. So do you know the 4 forces of the universe? Yeah, there's just only 4 forces in the universe. The gravitational force, right? Strong nuclear force, the one we'll be seeing right now, weak nuclear force, which we'll also see, and electrostatic force. Electrostatic force is actually magnetism. So the magnetism falls under that. Sometimes students get confused, like what is magnetism, right? Magnetism, it was this electron dipole thing, right? It was actually from electrostatics. So yeah, what's strong nuclear force? So strong nuclear force basically ki hoy. It's actually not your traditional force that you know of. It's a particle that keeps moving around between 2 of these. The particle they exchange it. And as the particles are exchanging, right, what happens is they become like paired up. Pair up. It's like table tennis like 2 players, and there's another table next to you. There's another table next to you. There are 2 players there as well, and you're playing table tennis here, right? Are they involved in the game? No, right? Can they be involved in the game? Not really. I mean, or arc table right? I mean, no one's there to play with them. So, but this becomes a perfect rally when Aura continuously go to the right? So they're exchanging this particle here and they become like a pair like that. So here's the interesting thing. The strong nuclear force tries to make everyone play. So do you understand this? What's happening here? So you're playing table tennis, right? Next shot okay dila, dila. But before that, the other 2 people start to feel like they're out of the game. Or they cover ball. So there's enough time to keep everyone what? Interested, right? As a result, baki particles they stick along. But are they like in the best possible attraction out there? No, isn't there a bit of weakness there? They're still, not been involved all the time, right? So I prefer Koreki to leave, right? That's what they want to do. They want to go and have their own, match, right? And that's when they undergo radioactive decay. Okay, so they're just somehow clinging on. They'll go away. To begin with, right? So that's basically what's happening. Exchange particle bola hoy. Exchange particle is what keeps your attraction going on, right? But এটা খালি কখন হয়? Adjacent particles হয়. So remember that it has to go the other way like that. ওটা possible না. Just like a table ছেড়ে পিছের টেবিলে আরেকজনের কাছে বল যাওয়া, that's not possible. So therefore only the adjacent particles somehow cling on. If I have like another neutron show up here, that's physically not possible to exist. And this exchange can only happen between what and what? A proton and a neutron, okay? Not a neutron, not a proton. All right. So yeah, anyways, it's called an exchange mechanism. We don't have it in our syllabus. Right, so let's start the hierarchy. Show my screen. It's a table we need to fill up. But they have enough protons that they can keep the other neutrons excited and interested. Okay, but at a particular point, there are too many neutrons, it never works. I'll give you an example, okay? So you know chlorine 37, right? It's unstable, right? Why doesn't chlorine 40 exist? Yeah, but why doesn't it exist? Because when you have 17 protons, 18 protons ধরে রাখতে পারে, 19 ধরে রাখতে পারে, 20 ধরে রাখতে পারে, that's chlorine 17, right? But 21, 22, 23, 24 যখন চলে আসে, that's the number of neutrons extra, right? This 17 protons can't really hold on to that. So therefore that element doesn't even exist. That's why you won't have isotopes of any number. There's a barrier to it. You'll find that after a certain number, that isotope is not there anymore, right? Okay. I'll ask you the hierarchy. Help me out with the hierarchy of an atom, okay? So the first thing is we have what we have discussed earlier, the atom. So this is your atom as we know. The atom that we know consists of three parts or three particles out there: a proton, a neutron, and in the shell that's around it, what does it contain? Electron, right? So that's the typical atom that we know of. Now, there's this term used in science called fundamental particles. Fundamental particles key, the alphabets. English alphabets হচ্ছে the fundamental building block of language, right? ওইটার উপরে বেস করে তুমি কি বানাতে পারবা? Words, multiple words actually combine করলে কি হয়? Sentences, right? আমরা যেটা originally assume করতাম that words were the foundation of language. Like, let's say cat, that's it. A cat যে CAT দিয়ে বানানো এটা আমরা জানতাম না. And that's what an atom is. An atom is basically a cat. That's a word cat. So the point I'm trying to make is that that's what we thought. But then we realized you can actually break that down. John Dalton actually made that mistake. He said that a atom is indivisible. That was his statement. Very famous 1800. He said the baseline of universe is an atom, right? But then we found that the atom can be actually broken down into subatomic particles, right? What are the subatomic particles out there? যেটা বললাম মাত্র. You have protons, তারপর কি? Neutrons, and electrons. And these became your alphabets. And এটা নিয়ে কিন্তু হচ্ছে everything that you see around you can be explained very well. Because আমরা যেটা এখন শিখতে যাবো, এটা যদি কেউ নাও জানে, they probably will do very well in science. They don't need to know this, right? Yes, so we made the bomb without knowing so many things, right? So, but still people knowing this can't make the bomb. So you understand it's not that really important, right? Anyways, so you have your protons, neutrons, and electrons out there. And this was believed to be it until 1964, where a couple of scientists figured out the problem we just realized. That proton and proton what each other, repel each other, and a neutron has to come in to keep them together. But then they realized that electrostatic force data, I normally believe for you, right, can't be available there. So how is a neutral particle holding on to a proton? So that's when they realized that something must be going on inside, right? So তোমরা যদি oxygen, say water কি imagine করো, molecule, right? Oxygen and hydrogen. And let's assume that that's it. They're just sticking together. That doesn't make sense. Why are they sticking together? Chemical bonds, right? And what's the thing that's like interchanged to keep them together? Electrons, right? ওরা তখন realize করছে there must be something smaller inside protons, neutrons, and electrons for this. And they made a prediction, a bold prediction. They said that protons and neutrons can further be divided. It's like, ABC বললাম number, we reached ABC right now. But it's apparent that ABC can further break down করা যায়. In science, that's possible. And that's when they classify two main categories of particles out there, called quarks and leptons. The people who came up with quarks, right, did not come up with leptons. They said just quarks exist for it. So the first category we'll be learning today is this very unique group of particles out there called the quarks. So the origin of the term quark is not a mystery. We know where the word came from. So the word quark, right, has no meaning. They just came up with a random word. That's the true story. No, it is what it is. That's because there's no background to this word. Say, what is a quark, right? They had to name something, they just said quark, right? I don't know why they said that word, but that is it. There's nothing to it. So quark is this further breakdown of protons, neutrons, and electrons. And this is where things get very strange in atomic physics, right? So let me explain কি হচ্ছে এখানে। এই কোয়ার্কটাকে আমরা বলি fundamental particle, which means that this is it at the moment though, that this is the baseline of the universe. Fundamental particles বলা হয় যাকে। And a fundamental particle quark যেটা is responsible for exerting a new type of force we discovered. What is it? The strong nuclear force. এটা তোমাদের MCQ তে প্রায় আসে, strong nuclear force. So remember this, okay? Key জিনিসটা, that strong nuclear force কারা exert করতে পারে? Quarks, right? And এই যে proton আর neutron এর মধ্যে যে strong nuclear force exist করে, must be a quark inside them that does that. So what are the quarks out there? So the prediction they made was that there must be 6 quarks out there, but they didn't find the 6 quarks. Okay, এটার originটা is something like the periodic table. Do you know the origin of the periodic table? The Mendeleev periodic table. So Mendeleev, this physicist, chemist, he basically came up with an idea that he'll place all the elements based on their mass and based on the reactivity, right? And he made a table, right? The table that group 1, group 2, and whatnot. And ওই যখন table বানায় first, right? 30% of it was filled, 70% was empty. He left out boxes. যে ধরো element proton number 6, 7 এখনো discover হয় নাই, 8 discover হয় নাই, element 9, 7, 8 পরে discover হয়. So that's how we came to know all the elements out there, right? এখানে same একটা story ছিল. They knew that there must be 6 of them out there based on the interaction that they figured out, but they didn't find 6 of them. They only found 2 of them, eventually 3 of them. বাকি 3টা ওরা fill up করে through that fill in the blanks, right? So what are the quarks that eventually came out? Quarks এর নামগুলো হচ্ছে the scientists who actually worked on this had some weird naming scheme they used. They're called flavors. Yes. So they call these the flavors of your quark. So there are 6 flavors of quarks out there, okay? Because they said that these are like ingredients that mix up and create things in the universe. So the first one is your up quark. So that's the first quark. You have a quark called the down quark. It's a particle name, by the way, okay? Then you have your top quark. Then you have your bottom quark. Then you have your strange quark. And then you have your charm quark. These are actual names of particles out there, okay? Now, the thing is, it was even worse. They eventually realized that they're getting too much away with the naming of it, but they had to tone it down. So up, down, ঠিক ছিল, top and bottom wasn't top and bottom. You know their original name? It was truth and beauty. Yeah. So I think eventually scientific community was like, you have to stop with this name. They went to top and bottom. Strange and charm to this Laura. Strange because strange quark is actually strange. It does things that are not normal, okay? But charm, I don't know why it's still there. Anyways, these are the quarks out there. So a quark gulo ki? A quark guloর property হচ্ছে they can't exist on their own, and that's why we never found them. But it took such a long time to figure them out because they don't exist on their own. They always pair up and bind up. And whenever they pair up and bind up together, they form protons and neutrons. That's why we never found them individually, right? How did we find them eventually? So it was like a multi-billion-dollar experiment that led to their discovery. It's called the particle accelerator. So it's CERN, Stanford Linear Accelerator. There are many accelerators out there. They took a proton and another proton and make the 2 protons collide at extremely high velocities, and that scattered protons onto pieces, right? What can they found these things inside? Okay, so they're naturally powerful, and when they're nearby, they for a few milliseconds and then disappear. Okay, so you won't really find a quark in front of whatever you're made up of, right? Because you're made up of a combination of quarks. We see that right now. So quark are why you find them in the charge are not whole charge. The charge are the attraction. So the charge of a quark is plus 1 by 3, down minus 1 by 3, top is plus 1 by 3, bottom is minus 1 by 3, strange is minus 1 by 3, charge is plus 1 by 3. If I make a mistake, I'll write this way, but I think that's the charge. Okay. So yeah, these are the charges of your quarks out there. From chemistry, probably charges don't really exist individually as fractions, right? But these are attractions, right? And they don't exist individually as fractions as well. So they'll have to combine to form what numbers? Whole numbers. And if you have some idea of math, what kind of combination is appropriate to make a whole number? Pairs or triplets? Think about it. Can you combine 2 of these here to make a whole number? Combine 2 of these to make a whole number. But two particles. That's what my question was. Can you make them like a whole number with just 2? Not possible. Okay, so they always have to come in threes here, and a 3 combination get a name দেওয়া হয়. Okay, so yeah, these are, I mean, I'll get to it, don't worry, but the point I'm trying to make is that they always have to combine, and they have to become a what number in order to combine a whole number, right? So these are the quarks out there, and এগুলো হচ্ছে combines to form protons, neutrons, and everything in the universe. They're the fundamental particles of the universe. Okay, now এটা করতে করতে we realize that there's another force in the universe, an opposing force called the, not really opposing force, but similar force called a weak nuclear force. This was a strong one. So there's something called the weak nuclear force. That's when we started wondering who applies that, right? And এখানে একটা জিনিস missing though. Electron দেখা যাচ্ছে না এখানে in this thing. Electron নাই এখানে, right? So that's when came along another group of particles called the leptons. Okay, leptons are also fundamental particles. They can't be further broken down. That's what I mean by fundamental particles. And these are responsible for weak nuclear force. Weak nuclear force is the force exerted during a beta decay. Beta particle যখন breakdown করে, there's a force exerted that causes the beta particle to fly off with excess energy. That force is the weak nuclear force. It is weak compared to this. That's why they call it weak. But on its own, it's actually not that weak. It's stronger than gravity. It's similar to electrostatic forces, right? So this is weak nuclear force. এগুলোর নামগুলো হচ্ছে pretty straightforward actually. So the first lepton, right, is actually the electron. So electron is a lepton. Electron charge হচ্ছে -1. But this electron comes with a pair. Remember we saw in the beta decay? ওইটা খুব important. It's called an electron neutrino. So neutrino is this class of particles out there যাদের charge 0. Our symbol টা একটু দিই তোমাদের পাশে symbol গুলো লাগবে. Electron neutrino is a V, like a small v with a subscript E. Okay, so that question again, does leptons and quarks both add up to form protons? No. Protons are made up of only quarks. Lepton is a different class of particles. I'll show the combination, don't worry, like combine there. So you have electron neutrino, then you have muon neutrino. একটা জিনিস বলে দিই যে এখানে most of the stuff that I'm teaching you right now কোনটাই লাগবে না, just নামটা জানতে হবে, just এখান থেকে maybe 3-4টা হচ্ছে তোমাদের মেমোরাইজ করতে হবে, okay? Rest of them just table দিছে সিলেবাসে তার জন্য পড়াচ্ছি. This is your muon neutrino, mu, yes, -1 0, and then you have tau, tau, and tau neutrinos. Tau is a very famous Greek alphabet. It's the origin of T. So tau neutrino, -1 and 0. Okay. Now, what are the symbols for up, down, top, bottom? Strange term, super easy. Is there for the first alphabet? Okay, but small, lowercase. So up U, down, T, B, S, C. So these are their symbols out there. Okay, so these are the quarks, and these are the leptons out there. And yes, as I just mentioned multiple times before, এগুলা সব combine করে you have the subatomic particles that make up the universe. At this moment, okay, I'll always have to add, at this moment, this is what we believe is the foundation of the universe. Okay, so if you go down to the building blocks of the universe, these are the particles out there. But it keeps changing, and within the discovery of these, right, more particles showed up. Not part of these, but they exist. One of them is called the Higgs boson particle. It is the particle that's responsible for mass in the universe, right? Anything that has mass must have the Higgs boson particle out there. But there's something called a photon, which we learned in A2. It's an electromagnetic particle. Then you have something called the W and Z bosons. Type of particle. These are all particles responsible for the forces in the universe. And there's one mystery out there, the final frontier, the final mystery of the universe. No. It's gravity. I know it sounds very strange that we know about gravity, but gravity কিন্তু হচ্ছে এখনো discover করা হয় না what gives gravity. We still don't know that. We have found everything. What provides, electrostatic force, magnetic force, strong nuclear, weak nuclear. Everything can be explained in science, but gravity can't be explained. What can be explained though is the effect of gravity. That's what we do. Projectiles পড়ো না তোমরা A2 থেকে we learn about the forces of gravity and the formula of how planets and stars revolve around them. That's the effect of gravity. But when you go down into a particle, right down to the smallest part of the particle, right, we have found every property K দেয়, charge K দেয়, field K দেয়, mass K দেয়, but we haven't found the particle that gives what though? Gravity, right? It is proposed that there's this particle called a gravitron. It's that the particle that provides gravity that's theoretically there, but zero evidence of it has been found through experiments yet. Okay, it's the final branch of physics. It's called the grand unification theory, where all the four forces can be combined together only if we can find out what gravitron is, which we can't yet or haven't yet. Okay, so anyways, these are the particles out there. Now, can these be further broken down? Right, AJ, up, down, right? So we thought no, but as I said earlier, at this moment, very recently, we now believe yes, they can be further broken down. But here's the strange part: if you further break them down, right, there are no more particles; they become energies, and they're called strings. They're like bands of rubber bands, right? Strings are moton energy. Or energy গুলো হচ্ছে কিসে convert হয়ে যায় when we interact with them? Mass. There's this energy mass interaction. Not part of our syllabus. So we will draw a line here. Okay. Now, এটা করতে করতে we stumble upon a new category of particles out there. এটা আমাদের শিখতে হবে. These are called antiparticles. So what is an antiparticle? Antiparticle হচ্ছে এই যে বলছিলাম না the experiment that produced all the quarks and everything. ওইখানে we discovered these particles called antiparticles, right? এই antiparticles এর properties কি? So the antiparticles are exactly identical to particles. So if I gave you an antiparticle in front of you right now, right, you wouldn't be able to recognize that it's an antiparticle. It's exactly same, mass same, color same, density same, every single thing is same, even the charge is same. The difference is the nature of the charge. একটা plus, article minus. So antiparticles are basically particular mirror, charge mirrors. So proton is what? +1. Anti-proton that exists for it has a charge of what? -1. But what does it look like? What does it weigh like? Exactly like a proton, right? So ওগুলাকে আমরা show করি এই symbol দিয়ে. Basically, we write down them with put in what in front of their name? Anti. That's it. Okay. So anti. So anti up, anti down. These are all like that. Can you predict for me what's the charge of anti up? Exactly, -2/3. What's the charge of anti down? Positive? 1/3. Now here's a new question for you. Remember I told you that quarks can't be combined in pairs because 1/3, 2/3 করলে তিনটা লাগে সবসময়. Can I combine quarks and anti-quarks and two of them to make a whole number? Yes, অনেক easy. কেমনে দেখো? এই যে এটা +2/3, এটা -1/3. What do they combine and become? 0, right? So it is possible for your quarks to combine in what nature? Pairs. But they have to be a combination of what and what? A quark and an anti-quark. It's impossible for a quark and a quark to combine. It's only possible when a quark and an anti-quark combine. Okay? They have names. We'll learn their names in a bit. So exactly charge to right, so this is minus, this is plus, this is minus, this is plus, this is plus, this is minus. Right, so similarly, এগুলারও হচ্ছে তোমার antiparticles exist করে. If they combine, do they annihilate and release energy? No. When they combine, they don't actually come in contact with each other. They form like a pair that revolves around each other because particle antiparticle collide into it's a problem. They destroy each other entirely. Okay, and that's a form of energy that's used in many places, but we don't have that. Okay, so I'm going to A2 but just quark and anti-quark, when they combine, right, they don't literally combine as in they join. They form like a binding pair. They're just revolving around each other. Okay, not in touch with each other. Right, so what are the antiparticles here? এগুলার antiparticles এর নামগুলো হচ্ছে similar, but হচ্ছে কিছুগুলোর নাম differently দেওয়া হয়. For example, electron এর antiparticle এর নাম হচ্ছে positron. Electron, right? Positron, or you can say positive electron. It's the same thing, or a short form of positron bole. Now here's the strange thing though. A neutrino is 0. ওটার antiparticle এর charge কি হবে? Negative zero or positive zero? Zero plus minus nine, right? So what's different about it? Huh? No, like if I give you like a what is this electron neutrino and an anti-electron neutrino, right? What would be different about them? Tell her, why would it be an anti-electron neutrino? Huh? Yeah, but anti-electron neutrino does exist. So what's different about it? No, so turns out it's a little challenging for an A-level student. Where does charge come from? What's the origin of charge? Spin. How things spin করে particles, so spin থেকে charge property আসে, okay? So ওই neutrino spin করে ওদের spinটা এরকম হয় that it gives a value of what? 0. Anti-neutrino spin করে, but কোন দিকে spin করে? উল্টা দিকে, which still gives a 0, but which way is the spin? The other way. So once you go into spin of particles, right, তখন দেখবে that they're very different. But if I just tell you the magnitude of the spin, what's same for them, right? 0 and 0. তার জন্য বুঝা যায় না, okay? So it's a spin property that exists, quite different for them. Achha, I know because eventually students will tell me like they're the same. Shabhi the same. Why is there anti there, right? It's because they do have a difference. It's the way they spin. Okay, right. So egla হচ্ছে same হবে. Just ওদের নামের সাথে হচ্ছে anti চলে আসবে. Yeah, they are generated in that experiment, the particle accelerator. Right. They spiral in opposite directions in a magnetic field. By the way, what's the symbol for antiparticles? Symbol কি হবে? How do you denote that they're antiparticles? So what you do is you put a bar on top of them. Okay, so you put a bar down, one হচ্ছে they're antiparticles. Okay, same goes here as well. So these are all antiparticles here. So anti-electron, tau, anti-tau neutrino, anti-muon neutrino, anti-muon, and ওদের just difference কি হবে, the symbolটা হচ্ছে উপরে একটা bar চলে আসবে. Okay, right. So these are all the particles out there. Are you guys aware of permutation combination? Yes. Can you tell me if I have these many particles out there? Quite a particle আছে বলতে পারবেন in total? Yeah, 6, 12, 18, 24 particles out there, 24 combinations out there. Can you do permutation and combination and figure out the 24 ke jodi combine koro in different combinations, right? How many total combinations are possible? Yeah, factorial, 1 into 2 into 3. 6.2 into 10 to the power? 24. Number ছোট হওয়ার কথা, what did I do wrong? Oh, sorry, 12 factorial হবে, because what I meant was 24 কিন্তু leptons and quarks combined হয়ে যাচ্ছে. It's only the quarks that combine separately, right? My point is it's a very big number. That's a সোজা কথা. It's 4.79 billion different combinations out there. And that's what was actually the problem. When we performed the experiment, right, the CERN experiment, ওইখানে যখন particles বের হয়, the first experiment, remember this, we thought protons, neutrons, and ki thake universe electrons, right? This experiment was done, and we experimented data gave us 27,000 different new particles out there. It suddenly broke physics, because we thought that protons, neutrons, electrons, that's it, right? Where did they come from? They are basically combinations of all the quarks out there. We can think eventually slowly we found that they're all made up of these out there, okay? The strong nuclear force exerted ones and the weak nuclear force exerted ones. All right. Yeah, because the 27 are like the others, right? They're all combinations of these. So when you start to extract one by one what are they made up of, right? You end up with these only. There's nothing smaller than these. Yeah. Yeah, I mean, if it was just protons, electrons, and neutrons, things would have been much easier. But quarks today. Right. এখন একটু স্ক্রিনে we are almost at the end, so এই যে wrap up করে দেই। এই quarks combine যখন করে Again, they have names. So we have to give them names. So combination of quarks, any combination of quarks is known as hadrons. Okay, so hadron जो जिज्ञेस for exam what's a hadron? It's a combination of quark, any combination of quark. Now quarks don't combine just randomly. They combine in a particular manner. যেটা একটু আগে তোমাদেরকে আমি লজিক দিয়ে বোঝাতে চাচ্ছিলাম. They can either combine in pairs of 3 or they can combine as pairs, right, with a quark and an anti-quark. So whenever the combination is any 3 quark combination, ওগুলাকে আমরা ডাকি, this is very famous, baryons. And any 2 quark combination, by the way, so for exam quite a question is from this new topic, it's just these a combination okay. So any 2 quarks in particle antiparticle combination, particle antiparticle combination, এগুলাকে বলা হয় mesons. And some notable baryons and mesons তোমাদের জানতে হবে. The most famous baryon out there is the proton. Proton combination কি? Proton, এটা তোমাদের memorize করতে হবে, from what I have understood, up, up, down. তো 3টা quark combine হয়, up, up and down, ওরা এরকম করে float করতে থাকে, right? ওই flotation যে এই setupটা, ওরা combination is collectively known as what? A proton. Up এর charge কি? Plus 2/3, up at charge key plus 2/3, that's plus 4/3. সাথে একটা down, that's minus 1/3. What's the total? Plus 1, right? And the other famous baryon is your neutron, which is up, down, down. Because up is plus 2/3, down is minus 1/3, down is minus 1/3, total 0. Okay, so yeah, these are the ones that you need to know. Up, up, down, and up, down, down. Protons and neutrons are combination. Mesons অনেক famous আছে, বা তোমাদের সিলেবাস মনে দেখিনি আমি. You have ions, pions, তারপর হচ্ছে sigma, delta. These are all different types of mesons out there. লাগবে না hopefully. Okay, it's like an NXL thing. Cambridge এখনো দেখিনি, Cambridge what I've seen so far. So yeah, there you go. The hierarchy of particles in the universe. Mesons? Mesons don't make anything. So they're usually found when supernova takes place. Supernova is a star. Supernova with only particles mesons. Mesons below is part of cosmic radiation, and these mesons fly through space and enters the Earth's atmosphere and randomly Earth. No, there are many more variants. Baryons, you have a proton, neutron, you have delta, which is interesting quark. It's very heavy, right? More heavy than protons and neutrons, but highly unstable. So that's the artificial for a brain rate. So they don't stay stable. These are the most stable, proton and neutron. No, which is protons and neutrons. They go up, down, range, star, right? It's actually how we discovered them. Up and down, were first discovered, because they're found everywhere very easily. And the reason behind that is very stable. But then as you keep going down, right, they're very unstable. So strange and charge, for example, are highly unstable. So therefore, you never find them naturally. So we have to do experiments like the particle accelerator, where they collide and produce billions of small particles. Within those, we can see them appear for a nanosecond, and then they disappear, right? But here's the thing, though: you can take a strange quark and like a charm quark and a bottom quark, and you can combine to form a particle out there, which is a little bit more stable, and they last for longer, but still they decay, and they decay like radioactive decay. So you won't find them naturally out there. It's just like uranium. Uranium is not like synthesized naturally. It only comes from a supernova. Same thing goes here as well. So you won't find them naturally. Right. So how do we find uranium? Yeah. So before uranium decays, how did we find them? Because they're not supposed to exist. Is that your question? Yeah, good question. So uranium has a half-life of 300 million years, right? So if I give you 1 kilogram of uranium, like 1 kilogram of uranium, how much of it will decay in 200 million years? If the half-life is 200 million years, half of it, right? Now let's say I give you 1 trillion kilograms of uranium, right? In 200 million years, how many will you have? Half a trillion, right? And then after another 200 million years, how much will you have? Half of that, right? So it turns out when the universe formed, right, the amount of uranium out there, the parts that ended up on the earth and other places was a lot, right? And they have been decaying over the years. And we are at a stage where we still find some of them. Down the line, maybe another billion years in the future, what you are expecting might happen, that all the uranium has disappeared. Why? They've all decayed. But so far, the time has not gone by as much to make them entirely decay. It is believed that some of the very heavy elements out there, this element 119, যেটা periodic table পাবা না, ওটা apparently ছিল universe, but its half-life was 15 days. So you can imagine that within 100 years, it's all gone, right? So that's why we don't find that. But বাকিগুলো পাবা. The last element to disappear from the universe would be hydrogen. So every element out there has a decay half-life, even the most stable ones out there. And then the longest half-life is for hydrogen, which is like half a trillion year. So every half a trillion years, right, the number of hydrogen in the universe becomes half. So that's a lot of time. The universe is only 13 billion years old. So but there is this prediction that 10 to the power 15, 18, 20 years in the future, like trillion years in the future, right? Every element will disappear and the universe will be only a collection of strings, energy. That's it. And eventually that will disappear. It's called the cold death. Sorry? They exist. Oh, it's because of this particle called a boson. When you have a plus and a minus, this particle basically keeps moving around, so they stick together. And when you have like a plus and a plus, the W bosons push away from each other. So therefore, there's that's how the universe works. আমাকে পাঠিয়েছিলেন পাইনি এটা পড়ে ওই যে এটা কবে মানে অক্টোবর next year. So you'll take a break now. আচ্ছা মানে পুরোটা শেষ করবা পরীক্ষাটা ক্লিয়ার দিব না আচ্ছা বুঝছি আচ্ছা তো তুমি স্ক্র্যাচ থেকে এই স্টাফ শুরু করবে আচ্ছা ঠিক আছে আচ্ছা এটা কি বলছে the voltmeter is connected to a circuit polarity shown.
So I want to circuit question গুলো অনেক confusion হয় especially when there is cyclic resistor
cyclic resistor. হ্যাঁ আমি হচ্ছে নেক্সট ক্লাস থেকে ওটাই করবো যে তোমাদের হচ্ছে রিভিউ কোশ্চেন গুলো আছে এন্ড যে এমসিকিউ গুলো সবগুলো করবো
আপনার রিভিউ কোশ্চেন গুলো অনেকগুলো করছি 20% of them is just electric field দিয়ে
হ্যাঁ এটা অ্যাকচুয়ালি হ্যাঁ না ওটা স্কিপ করো এটা অ্যাকচুয়ালি নাইস বাট ওই যে আমি যেটা করবো যে ওয়েভস এন্ড ইলেকট্রিসিটি যত কোয়েশ্চেন আছে ওগুলো আগে করবো বিকজ বাকি সবগুলো হচ্ছে ম্যানেজ করা যায় কিন্তু ওয়েভস ইলেকট্রিসিটি না পারলে ইটস আ প্রবলেম contact দাও এখানে what is the two readings of the voltmeter P and Q 0 and 3 P তে হবে 0 আর Q তে হবে 3
No, sir, it's 3 and 6, I think.
oh sorry this is the battery here sorry I forgot I thought it's battery ছাড়া আচ্ছা তাহলে দেখি so you have battery here and resistor here আর তোমার হচ্ছে এখানে voltmeter is connected between this point and that point perfect right so তুমি যেটা নোটিস করবে যে এখান থেকে চার্জ যাচ্ছে 3 ভোল্টস নিয়ে 3 ভোল্টস নিয়ে তারপর এই পয়েন্টে আসতেছে 3 ভোল্টস নিয়ে তারপর এখানে এন্টার করতেছে with what 3 volts right আর এখানে এই যে চার্জটা এখান থেকে বের হচ্ছে 3 ভোল্টস নিয়ে ওই দিকে যাচ্ছে রাইট ওইদিকে গিয়ে এই লুপের মধ্যে এখানে ব্যাক করতেছে তো এটা 3 ভোল্টস আর এটা 3 ভোল্টস যদি তুমি এটাকে একটা সেপারেট লুপ কনসিডার করো forget this circuit exists which is Kirchhoff's second law তাহলে এই লুপে চার্জটা কিভাবে গিয়ে এভাবে গিয়ে এখানে আসবে না এখানে কিছু যাচ্ছে তো আই নো বাট এদিক দিয়ে এদিকে এন্টার করতেছে না আর এটার থেকে এদিক দিয়ে সে এদিকে যাচ্ছে না সো বোথ অফ দেম উইল অ্যাড আপ এট দিস পয়েন্ট
স্যার এখান দিয়ে যাওয়ার জন্য তো রেজিস্টারটা দিয়ে পাস করবে না সো ওয়ান্টেড লুজ চার্জ
lose charge হ্যাঁ বাট না I'm trying to show the direction তারপর আমরা পজিশন চেঞ্জ করব সো এট দিস পয়েন্ট যদি হচ্ছে তুমি এদিক দিয়ে যাও রাইট এদিক দিয়ে গিয়ে হচ্ছে এদিক দিয়ে এন্টার করো আর এটা এদিক দিয়ে এন্টার করো তাহলে বেসিক্যালি ইউ হ্যাভ টু অ্যাড देम আউট আচ্ছা এখন যদি আমরা এই জিনিসটাকে আমি খুলে এই জিনিসটাকে খুলে আমি যদি এটা এখানে নিয়ে আসি রাইট তাহলে কি হচ্ছে এদিক দিয়ে যাচ্ছে এদিক দিয়ে গিয়ে এটার ভিতর দিয়ে ট্রাভেল করে এখানে আসতেছে আর এটারটা জাস্ট স্ট্রেট এদিকে চলে আসতেছে সো এই ভোল্টেজটা একদম ইউজ হচ্ছে না আর এটা পুরোটা ইউজ আপ হয়ে যাচ্ছে বিফোর রিচেস হিয়ার রাইট আর প্রিভিয়াসটার মধ্যে হচ্ছে এটা পুরোটা ইউজ আপ হয়ে যাচ্ছে এটা ইউজ আপ হচ্ছে না সো তোমার অপশন হবে হচ্ছে এখানে যখন দুইটা আসতেছে 3 and 3
সো আমি ওটা
3 and 3
না না অ্যানসার 3 and 6 বাট আমি 3 and 3
3 and 6 হচ্ছে D Q তে 6 C হওয়ার কথা 3 and 3 হওয়ার কথা
আমি ওটাই দিছিলাম বাট দেন মার্কস মানে স্যার অনেকগুলো লাইক ভিডিওস আছে লাইক অল অফ देम 3 and 6
তাই
হ্যাঁ
C answer 3 and 3 is C 3 and 6 is D then without taking question dollar না যেন 6 হওয়ার কোনো চান্স নাই 6 আমি বলি 6 কখন হবে এই ব্যাটারিটা যদি উল্টা দিকে পয়েন্ট করতে যে এটা যদি বড় থাকতো এটা যদি ছোট থাকতো এইটা এদিকে আসতেছে এইটা এদিকে আসতেছে দুইটা একসাথে আসলে হচ্ছে 6 হতে পারতো
সো মার্কসিমাম বের করছি
3 and 3 then again 3 and 3 or chance তোমার হচ্ছে May June 2311 so I'm going to take the signing contact is move to NP for the potentiometer and then to Q what are the two readings on the voltmeter
so 37D
পিটা বুঝছি, কিউটা অ্যাকচুয়ালি আমার হচ্ছে না। পিটা হচ্ছে বলে দিয়ে, পিটা হচ্ছে যখন এখানে থাকে তখন ইটস ভেরি ইজি, ইটস জাস্ট দিস লুপ, তো এখানে কিছু নাই, জাস্ট এই 3 ভোল্টে শো করবে। এখানে থেকে 6 হওয়ার জন্য তো এই চার্জটা দিতে যাবে, it'll use up the voltage from there. আর এখান থেকে হচ্ছে এটা আসতেছে, it'll go this way, so এখানকার পোটেনশিয়ালটা এটা জিরো, এটা জিরো, দেখি হ্যাঁ এটা জিরো, 6 ছোট, so this is 3, this is 0, this is 3, এটা একটা ওয়ে আছে, বাট মেকশিফট হবে, আমি জাস্ট বলি, I'll see if I can give a better way of explaining this. তো যদি একটা ব্যাটারি থাকে এখানে এভাবে, what is the voltage across this? ধরো ভোল্টমিটারটা এখানে কানেক্ট করলাম, ভোল্টেজ হবে +3 volts। যদি আমার ব্যাটারিটা হচ্ছে উল্টা হয়, what would the voltage be? -3 volts, right? So আমি যদি এখান থেকে একটা ভোল্টমিটার কানেক্ট করি এই পয়েন্টটাতে, রাইট, তাহলে ও কি করে এইটার এটা পোটেনশিয়াল ডিফারেন্স বের করে, ডিফারেন্সটা। সো এখানে যদি +3 volts হয় আর এটা হচ্ছে -3 volts হয়, ডিফারেন্সটা ইন টার্মস অফ ভোল্টমিটার would be this minus that, so 3 volts minus 3 volts, so total 6 volts potential difference show করবে। That's in terms of voltmeter, but তোমার কোশ্চেনটা যেটা, ওটা আমি অ্যাকচুয়ালি সলিউশন পাচ্ছি না, যে এটার ভিতর দিয়ে গেলে তো হচ্ছে it will lose energy and then come here, so the 3 থাকবে। I am guessing একটা জিনিস হচ্ছে এখানে, আমি যেটা কনফার্ম করবো, এখানে একটা ভোল্টমিটার সিরিজে কানেক্টেড না? If a voltmeter is connected in series, what's the current through it? Do you know voltmeter একটা প্রবলেম ছিল? It has what resistance? So এই সার্কিটে কারেন্ট কিন্তু ফ্লো করতেছেই না। Okay, so this voltmeter is basically taking the reading from this point and ওই পয়েন্টটাতে, এই পয়েন্ট is -3 because the battery is pointed the other way, আর এই পয়েন্ট হচ্ছে +3 because the battery is pointed the other way. So it's basically finding the difference of the charges at these 2 points. That idea যে কারেন্টটা যাবে দিকতে তারপর এনার্জি ইউজ আপ হয়ে যাবে, সম্ভব না, because if a voltmeter is in series, it doesn't allow current to pass through. So that's probably the reason. Okay, I'll look into it if there's any better explanation. Elsewhere, the particles displacement, when you can enter the particles very good time. Compressions, rarefactions, 0. Answer is C. Yeah. So the idea is that this is displacement, right? And what's the gradient of a displacement diagram? Velocity, right? So JJ gradient should be highest, so you can velocity keep away. Highest, right? And JJ velocity highest K হবে highest, right? So the point গুলোতে যে ক্রস করতেছে না, এই পয়েন্ট গুলোতে তোমার হচ্ছে velocity highest and K highest. So যে পয়েন্ট গুলো ক্রস করতেছে ওগুলো হচ্ছে K highest হবে। So I think যে এটা তারপর এটা হচ্ছে যে এটা, so this should be the answer. See, the K is highest there, and why is it like নিচে কিছু নাই? Because হচ্ছে K is a scalar quantity, right? And in one cycle, if you look at this, it goes through maximum how many times? 1, 2, 3, 4, right? So যে 1, 2, 3, 4 এগুলা হচ্ছে না, because এখানে দুইবার হচ্ছে। Steepest gradient হচ্ছে highest velocity না, একবার, দুইবার, তিনবার, চারবার। So you need to have 4 peaks out there. Second question হচ্ছে peak গুলো কোথায় হবে, যেখানে তোমার steepness টা হয়।